one.
Alright, day 4. Here we're finally doing authentic science. So we are doing the spring experiment for anchoring the linear pattern. And I tell them that. Tell them the eye on the prize is that you start to understand what linear means. I wouldn't use that term at the beginning, but this is a experience we're going for. So you have an understanding that, yeah, when you put twice as much mass, you want to feel as well as understand, as well as be able to mathematically compute that you double the mass, you double the stretch. All right. Now, so quick highlight thing is right when students come in, have them measure something right away. I might put a line on the board and I stack the deck. I made the line a little weird ending just so they will possibly kind of have a big range in using the ruler to measure something. I might do something else that's a book or something else too. All right, the big prize here is we need 3 different slopes. So that can come from 3 different springs, and really we only have 2 and just this one extra one. So we have lots of these and only one of these for the whole school. If you don't have the springs, which they'll probably arrive, but if they don't, we have lots of options. Anything that'll give linear. You can do this with candy, but I happen to have ball bearings. So you can already see that one ball bearing, if it's small, is going to be 1 mass. One ball bearing, medium, is going to be bigger, and a big ball bearing is going to have a large mass. So that's going to give us 3 different slopes when we plot mass versus number of ball bearings. Then the last thing, really important, we want this one to go well, is the board meeting, our first board meeting. And remember, in 0, in rubric and files, there is discussion prompts if you want to kind of review. But the big idea is to orientate them to the graph. As much as it seems like they should know this, I don't think a lot of students come to the board meetings understanding the graphs. So we spend quite a bit of time. What is this axis? What is this axis? Does that make sense? Kelly, okay, yes. Sarah, what do you think this data point is? Oh, okay, it's 10 mass, 2 centimeters of stretch. And remember, we want big error bars. Everything is linear with big enough error bars. And then on here, we also have stretch equals 0.05 times mass. I have them write it out. Again, the advanced students can handle S equals 0.05 times M. Lots of students are not going to put that together and be confused. So I have them write it out. Stretch equals 0.05 times mass. And then of course we need a little bit of a schematic of our experimental setup, where here I have my diameter being 1 centimeter. Good luck.